this week we're going to be talking about the semantics of predicate logic and moving forward with further, more complicated symbolizations. Once again, that's what the exercises in the Logic Cafe will be for this week. And then we'll go back to derivations starting next week, and that's what we'll do both in week 9 and week 10, working on chapter 8. And then you'll be done. But in any case, what's semantics, once again? We covered semantics at the very beginning of our discussion of sentence logic, of SL. But what are we talking about when we're talking about semantics? All at once now. What is it?
It's just like how words are defined.
Well, it's meaning, right? I mean, just in general, the semantics of a language talks about the conventions regarding meanings. And so when you say that's just a matter of semantics, you're talking about, well, that depends on what you mean. And in formal languages as well, semantics have to do with meaning. And in SL, we worked out a particular interpretation of meaning that has to do with the truth conditions of sentences. So to understand the meaning of a sentence in SL is to understand exactly how the truth of the sentence varies with the truth values of the component parts, the atomic sentences that make it up. And the same general approach applies to predicate logic up to the quantifiers. Consider the universe of discourse consisting of all of the presidents of the United States through Obama. There actually were 43 of them, even though Obama is the 44th president of the United States. That's because one of them, Grover Cleveland, was president twice on 2 different occasions. He didn't get, wasn't a matter of being reelected immediately after his first term. There was an intervening president. He was, I think, or my notes say he was the 22nd and the 24th president of the United States. But in any case, there's 43 presidents of the United States through Obama. And let's say we let R equal the predicate enjoyed roast beef dinners, and B would be hated beets. And then you ask yourself, just contemplate this, what is the truth table? What would the truth table be, the complete truth table now, for all x, Rx, ampersand, Bx? Any thoughts on the matter? It would be all of the possible truth values for 43 variables, right?
Couldn't you just simplify it and make it the truth table of all of Rx, all of Bx, and then...
that would still be a very long truth table, wouldn't it? If you're
Yeah,
trying to
it's
do a
only
complete...
2 values.
Yeah, that's right. But it'd still, it'd be, what, 2 values for each of 43 presidents. So that's, it's a very long truth, it's a long truth table. It would have 86 lines in each one, right?
But couldn't you simplify and just say if all of Rx is true, if all of Rx is false?
Well, what you do is, instead of using truth tables in predicate logic, we talk about interpretations. We talk about various interpretations and what an interpretation is, and that's where I got ahead of myself here on the slide. An interpretation is an assignment of meaning which specifies, as we have in the center here, it specifies the universe of discourse, and it specifies the members of the universe of discourse to which any one place predicates apply. In this case, it's all of them. Okay, so we don't have to be particular about that. And the relationships between members of the universe of discourse to which any 2 or more place predicates apply. We don't have any in this particular interpretation. And the truth value of any 0 place predicate letters, that is atomic sentences that we may have. We don't have any of those. And finally, objects named by any individual constants. And we don't have any of those here either. We'll get to all of that stuff in a second. To say that all x, any sentence P, is true on an interpretation I, and sometimes they'll talk about more than one interpretation. We don't have to worry about that too much in the Logic Cafe, but it's true on a given interpretation if and only if the sentence is true on that interpretation for all of the names in the domain, in the universe of discourse. So if it's true for, you know, that sentence before that we had about the all x, rx, and bx, if that happens to be true conjointly for all presidents, they both loved roast beef and hated beets, that would be true on this interpretation in case it's true for every one of the 43 presidents. And obviously enough to say that exp, exists xp, is true on interpretation I, is to say that, the substitution instance of exp is true on that interpretation for at least one name. So in other words, instead of doing truth tables, we talk about interpretations, and that's what our semantics leads us to. All right, what I'd like to do is just move to a couple more symbolizations. Symbolization exercises, I should say. So let's go ahead and work on these 5 sentences, and let's see how that goes for you. We're working with quantifiers once again. David, what would you suggest for number 1?
I did the EX. I did PX and WX.
I'm sorry, what?
PX and WX.
Yeah, in parentheses, right?
In parentheses, yeah.
Okay, any questions about that one? There exists an x such that x is a philosopher and x is wise. Okay. Peter, do you have a suggestion about number 2?
There exists, or all,
Okay.
PX and RX.
Then you put px and rx. It says all philosophers are, no, all people are philosophers and rich. Because the universe of discourse is all people, right?
Right.
So that all ranges over. Now, what is our convention for? You're close, but it's not the convention for saying symbolizing universally quantified statements like this one. Somebody else.
Implies.
What, pardon me?
Implies.
Right.
Portion.
So, for everything, if X is a philosopher, then X is wealthy. It's the way we interpret universal quantified statements, okay? All right. Greg, how about number 3?
I have EX, and then parentheses, PX, and another parentheses, HX and WX.
And close both of those out. So there is an X such as X is a philosopher, and X is healthy, and X is wise. You could arrange those parentheses in either grouping, of course. You can distribute them in either way. Any questions about that one? Okay, Brad, how about number 4?
There exists an X such that PX and WX and not HX.
Yeah. And what will, there's a couple things to be said here. First is, I want you to be very, very careful about parentheses and making sure that whenever you are using these quantifiers, that you've got anything that's within the domain of that quantifier, whether it's existential or universal, has to be in parentheses in such a way so that it indicates, yes, this quantifier covers everything that's in here. So that's the first thing. Second thing is that we could also, just to clear things up, might make it neater. This is perfectly legitimate class issue. We could also use brackets. As things get more complicated, it sometimes is helpful to the eye anyway to alternate parentheses with brackets. Okay, number 5, Kevin.
For all x quantity, px implies quantity.
Hold on. All x.
Quantity px implies quantity hx and not rx.
So, if anybody's a philosopher, then they're healthy and they're not rich. They're poor. Any questions about that one? Okay, let's just run through a few more and then we'll be done. Okay, try these 5 out. Notice that we've got a much more complicated set of predicates. I think you can read them on your laptop. Yeah, I guess they're pretty legible up there too. So go ahead and work on those 5 and hang on. And report your status when you are finished with them. Michael, do you have a suggestion about number 1?
I don't know.
Pardon me?
No.
Okay. Chris?
For all x, wx implies mx.
For all x, wx, horseshoe, mx. Okay? Any questions about that? The only trick there is remembering, thinking through what's meant when it says only mammals and fish. You might have written down incorrectly all, mx, horseshoe, wx instead. This is correct. All right. Let's see. Alex Minor, how about number 2?
For all x, bracket mx implies.
I'm sorry, what?
parenthesis,
Quantity,
mx implies parenthesis bx or cx and close it off.
now, what is, this would say, among all living things, if the living thing is a mammal, then it's either a beluga or a cat.
Makes sense to me.
That says all mammals are belugas and cats.
But they are.
We don't care about whether they are or not, but that's not what the sentence says. So, instead, it doesn't, the number 2 doesn't say all mammals are belugas and cats. Instead, it says all belugas and cats are mammals. So how would you do that?
Just take what I said and reverse it.
Yeah. So, right?
Would it be and?
No.
I've met a beluga that's a cat.
If it's a beluga and a cat, it's not a mammal, then it doesn't exist.
Well, it's okay. We could have that as a sentence in our logic class, but that's not what the sentence says. It says all belugas are mammals and all cats are mammals. So if something's a beluga or a cat, then it's a mammal, right? Or not? I mean, when I say that, I don't mean I'm not just trying to drive it down your throats. When I ask you right, I mean if you don't see it, then I want to say it again in a way that makes it plainer. But it's a matter of trying to figure out what is the logic of the sentence. And it says, for anything, any living creature at all, because that's the universe of discourse, if it's a beluga or if it's a cat, then it's a mammal. And it doesn't say that everything that's both a beluga and a cat is a mammal. That would be the ampersand. Okay? That would be for all x, if x is a beluga and x is a cat, if it's both of those things, then it's a mammal. And whether or not there are any such things, that would be a different sentence. We could have had that as an exercise, goofy though it might have been. Peter, how about number 3?
Number 3, exists all, SX.
Wait. Exists all? Or all? I mean, which one do you want?
The A.
Okay. Yeah.
SX, horseshoe, bracketed MX or FX.
So, for all x, among all living things, that's our universal discourse, if x is a sea creature, then it's either a mammal or a fish. That's correct. Does everybody see that?
What about a sea turtle?
Is it a mammal or a fish?
It's a reptile.
It's a reptilian. So it's a lie. We're not asking whether 3 is true or not. We're just saying that's what it means. I mean, damn fine know about some of those sea creatures. There's some strange things in there. What's a jellyfish?
An invertebrate.
It's
Yeah, it's an
a
invert-
Cenarian, I believe.
A what?
Cenarian.
Cenarian. Is that the name of a subgenus or something?
No, it's a.
It's a sea
I
creature.
want to say it's a fruit family, but I'm not sure.
All right. Well, we don't care about that in logic.
Might be a phylum. No, it would be class or.
How about, oh, never mind.
Yes.
All right, how about number 4, Mark?
I went all the way up instead of 1.
I'm sorry?
Okay, 4.
4.
I have, there exists such an X that, LXG.
Looks good to me. There exists an x such that x is larger than the general Sherman tree. Questions about that one? And finally, Will Resch. What about number 5?
Oh, you had to pick me for this one?
Pardon me?
I'm not really sure if I got this one. I said not, EX,
Not the case that there exists an x.
WX and not FX.
Oh, they didn't put that in there? Say it again. Wx and what?
And not FX.
This says that there doesn't exist an x. There doesn't exist any living creature that's both a whale and not a fish.
I had some more.
Oh, there's more. Go ahead.
Horseshoe, AX,
Okay, all x.
FX implies not BX.
Not what?
BX.
I can't hear the letter B.
B.
Beluga, for beluga. All right.
Yeah.
Okay, so this says, all right, if it's not the case that X is a whale and not a fish, so that's, right? Got, I think, why do you want a curl in the second, on the, before FX?
What happened was, by this point on this slide, I was starting to get frustrated.
Oh, okay.
So I started writing things down.
All right. That's what I always do. Just write anything in there. Nathan.
For all x.
Okay.
And then
You're
w.
gonna do, you want to start all over again? I think we could have repaired that.
Yeah. Well, just for the first part.
I'm gonna take more space and write the whole thing out. Well, what would be wrong if no whale is a fish? If it's not the case that there exists an x, I want to start with that one, such that x is a whale and x is a fish. That seems to me like that captures the first part, doesn't it? Also, you could start it all, if it's the case, because we're going to have this as the antecedent of a conditional, it could also be for all x not. That's that same conjunction, right? Is that what you had?
Actually had for all x, wx implies not f of x. So if it's a
Yeah,
whale,
right,
it can't
that's
be a
right,
fish.
right, that would work too. But let's keep on with Will's way. Then, any fish is no beluga, then for all x, if x is a fish, I'm sorry, then not bx. Is that what you had, Will? I've forgotten.
Yeah, I just had that extra tilde in front of the FX. And the
Yeah,
first-
I think that's the,
That's
otherwise
the
it's
thing.
just like this. I think
Yeah.
you had it all fine, except you got mixed up with the negations.
Yeah.
This, I think, is correct. Does this look right to you, Nathan? You had a different version. Yours was for all x on this side, if x is a whale, then x is not a fish, right? That works too. Yes, Brad?
If you do it that way, can you pull the for all x out and only have one of them?
Not now. Yeah,
For the one that you just wrote under that,
Yeah.
could you take the implies out using the ampersands? So it's a whale and not a fish?
yeah, for all x. No, that just says that everything is, if everything is a whale and not a fish, if you put an ampersand. Right? This says if everything, if all living things are whales but not fish, right? Then the rest of it. Do you see that, Sam? Okay.
For the top, I have the first half of the top one, but then for the second half, after the implies, I have not e to the x,
Wait, not?
not e to the x. F of x implies vx.
That probably isn't. Usually, my first reaction is usually you wouldn't see the existential quantifier with a conditional. Okay? And what would that say? That says, if blah, 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 then it's not the case that there exists an x such that if it's a fish, then it's a beluga. The if then seems to be getting in the way of what we want to say. And it's not the case that there exists an x such that fx and bx, I think would work. Does that work or not? I'm listening for criticisms of this possibility.
I think replacing it with an and.
What? It seems like it works? Okay. This is the one that seems most congenial to me. And again, it depends on, the way you sort of, break up the sentences in your own mind to capture the meaning. I mean, it'll determine how you bracket things and how you, whether you use, for example, with the construction, if no whale is a fish, then one reasonable thing to say is, well, if it's not the case that there exists x such that x is a whale and x is a fish, that's the way you've done it here, but you might also want to say, for all living things, if it's a whale, then it isn't a fish. That captures that too. Let's work on this array of questions. There are 9 of them. Please work through the lot. What you did for number 1.
Said there exists an x such that c of x.
A little louder, please.
I said there exists an x such that c of x and o of x.
Some U.S. citizens are voters. There exists an x such that x is a citizen and x is a voter. Means there exist x's or an x. Could be either way. That looks correct to me. Any questions about that one? Will Resch, how about number 2?
Same thing, only with a universal quantifier.
Same thing? So you put CX and OX.
Yep.
Any suggestions about that? Nathan?
CX implies OX.
The convention, I mean, you don't want to say all X for everything. See, the universe of discourse is all people, Will, right? So if you put that, if you put CX and OX, what you're saying is everybody is a U.S. citizen. Everybody, all people, are U.S. citizens and voters, which isn't what you want to say. You want to say, as Nathan indicates, for all the people, that's the universe of discourse, for all the people who are citizens, all of U.S. citizens, all of them are voters. So you say all X, CX, horseshoe, OX. So that as a general rule, when you've got a universally quantified statement, you're looking for some sort of implication relationship. I mean, do you see how that works? I mean, if you were to say all X, CX, and OX, then you got everybody in the universe, every person there ever was and ever will be, is a U.S. citizen and is a voter.
Okay, yeah. I think what I did is I was just kind of going quickly, and I noticed that they were the same thing with different
Alright.
words at the beginning.
Gotcha.
So
Good. Okay, Adam, number 3.
For all X, CX implies not OX.
Yeah, so if somebody's a U.S. citizen, then they're not a voter. That's what it says. There are other ways of doing this, though. Any other suggestions? Josh?
I put not AX, CX implies OX.
You did what?
I said not universal,
It's not the case that,
universal quantifier. CX implies OX.
this doesn't say the same thing, though. What this says is that there's at least one U.S. citizen who's not a voter. What we're trying to do is no U.S. citizens are voters. You see that? It says it's not the case that all U.S. citizens are voters. That's what you got.
Could you say not existential quantifier CX and OX?
Yep. So here is an alternative. It's not the case that there is a person who is both a citizen and a U.S. citizen and a voter. Is that clear? And as a general rule, as you'll see, you'll get rules for this eventually, but you can't use them until you get them. You get rules that will just tell you that anytime you have an existential quantifier like that, well, actually, the rule would be, it comes out like this: all X is not the case. It's CX and OX. I mean, that would be the rule. Then you'll get another rule that distributes that through and can make an implication out of it. And we won't worry about that now. That'll be week 10. All right. So those are 2 alternatives for number 3. Kevin, what's number 4?
I had there exists an X such that CX and not OX.
Yep. Nathan?
Just a question. I mean, let's see how that's the only way we can really represent that, but the word some seems to indicate more than one.
Well, you know, and so I keep saying there is an X. It's my problem, okay? I keep using that particular convention for the exists X. That's just what I'm used to, and I won't be able to change my ways. I say there exists an X. In my mind, when I say that, I mean there is at least one, okay? And so this the existential quantifier covers the situation when there is one and when there is more than one, as long as it's not, it does not indicate that all of them are. It's that there's at least one.
Right. But what I'm saying though is that the word some seems to indicate that it's not just one.
That's acceptably qualified, though. I mean, even if that were the case, it's to say that there's at least one is covered by there's more than one, right?
Okay.
It's not. Those are not equivalent in meaning, but this allows for the case that you're thinking of when it's not just one, but it also allows for the case when there is just one. You think that that's simply ruled out by the logic of the English word some.
It just,
Seems that way to you?
yeah.
Max, did you have something? Did you-
Oh, I was gonna say that couldn't existential qualifier also include all? It could be all, but it could
It
be
could
less.
be, it just
So it's
doesn't
anywhere in the
imply
range
all.
from one to
Yeah, I mean,
all,
where you're
right?
saying exists
And
at
some
least
exist
one,
in that
that
range.
it allows for the possibility that all are, logically speaking. But it's not saying that.
Yeah, that's what I'm saying. I'm saying that some is in the range.
So if
between
you
one
know,
and all.
well, for example, if you know that all US citizens are voters, if you knew that,
I was just trying
which is
to
number
clarify.
two, if you knew that, you could, that implies that at least one is.
No, I was just trying to clarify this.
Okay, yeah, right, okay. Alex Minor, how about number 5?
There exists an X such that Rx and OX.
Yeah. Any questions? Just the same as some of the others that you used as one, just talking about residents instead of citizens. All right, now number 6, David?
I said not existential X, parentheses, RX and CX, and parentheses, and OX.
So if I got this right, it's not the case that there exists an X, RX, and CX?
Yeah.
I think you want curl CX?
Oh yeah, curl CX.
Okay. And then what?
And OX. With parentheses around all that.
Okay, so you got, it's not the case that there exists an X such that X is a resident and not a citizen who's also a voter. Seem right? Looks good to me. All right, how about 7, Nathan?
For all x, not OX and RX implies not CX.
Okay, so I got something in a bracket. So not, what, say it again?
Not OX
Mm-hmm.
and RX
Implies,
not CX.
that says for all X, if X is a resident and doesn't vote, then they're not citizens. Is that clear? I think that's right. Looks right to me. All right, Mark, number 8.
I have all X. OX implies not RX.
OX implies, implies what?
Not RX.
Okay, so if X is a voter, then X isn't a U.S. resident for all X. That seems right to me. There are other ways of doing this. Anyone have another suggestion? Okay, it could be not the case there exists an X such that X is a voter and X is a resident. And finally, number 9, Greg.
I have universal qualifier, and then OX implies CX.
CX. Yep. Sometimes people might be inclined to reverse that and swap the antecedent and consequent. But that would be a mistake, because what this says is, if somebody is a voter, then they are a citizen. Any questions about any of these? All right. Here are a bunch more different different interpretation for the variables. Josh, how about number 1?
CX plus WX
BX what?
plus WX.
Once again, that says all living things are both belugas and whales. What do you want to do, Josh? Anybody else?
Make it a horseshoe.
Peter, yeah, that's all. Once again, for universal quantifiers, what this says is, for all living things, if it's a beluga, then it's a whale. Okay? All right. Number 2, Peter.
I actually put the exact same thing.
Yep. Now, Nathan, your question was, now this is what I would say, this is what the Logic Cafe says. It's, you know, it imagines that if this comes up in a conversation, or if it's, you know, under normal circumstances, you probably wouldn't be picking out a single beluga to say that it's a whale. But your point was that you sure could interpret the English that way. I mean, there's no reason why you wouldn't mean that there is a beluga such that it's a whale. So you could have exists X, BX, and WX. That would have been acceptable to me, because I understand what you're talking about, but not acceptable to the silly computer program, the Logic Cafe, because he has chosen that interpretation. That's another place where I would sort of wish that he used a different example. Andy, what did you do for number 3?
Everything X, I mean, EX, CX, and CXG.
There is something that's a living thing. There's a living thing that is a cat, and it's climbing the General Sherman tree. Any questions about that? That's right. All right. Eric, I can't remember where I've asked you to do 1, but why don't you do number 4 for us?
Okay. For all x, CXG implies NX.
So, for all living things, if X is climbing the General Sherman tree, then X is living in North America. That's not quite complete yet.
X is a cat and climbing the General
Did you
Sherman
say that before?
No, I did not.
Okay, all right, so let me see if I can fit all that in. All right. Okay. Whoops. If X is a cat, and if X is climbing the General Sherman tree, then that cat lives in North America. Now, what's really crucial about this one, and we'll see another one in a second where this changes, but the cat referred to in the last part of this sentence is the same cat as referred to in the first part of the sentence, and so you need to make sure that that quantifier that's quantifying over the cat is still maintained about the thing that's living in North America. In other words, the quantifier has to embrace the entire sentence. For now, though, we've certainly spent enough time on these particular problems. I'll hang around to talk with anybody who wishes to talk about that or any other issue further, but class is formally over.